Assalamualaikum warahmatullahi wabarakatuh and good day. This is for the example that cover composite beam and reinforced concrete beam. This is the example for the composite beam. Okay, the composite beam in figure 1A is made of wood and reinforced with a steel strap located on its bottom side. If the beam is subjected to a bending moment of m equals to 2 kilonewton meter, determine the normal stress at point B and C. Take modulus of elasticity. Wood is 12 gigapascal and modulus of elasticity of steel is 200 gigapascal. Okay, for the first step is to find the section properties. Okay, since steel has a greater stiffness than wood, which is modulus of elasticity steel more than modulus of elasticity wood, the width of the wood is reduced to an equivalent width of steel. For this to be the case, N equals to EW divided by EST, which is EW is modulus of elasticity of wood, and then divided by modulus of elasticity of steel. Okay, so we can use this equation. Okay, B for the steel equals to NBW. Okay, equals to N 12 divided by 200 times by 150 mm, and then the B for steel is 9 mm. Okay, the transform section is shown in figure 1B. Okay, the second step is to find the centroid of beam. The location of the centroid natural axis calculate from the bottom of the section is y bar equals to summation of y bar time area divided by summation of area. So y bar, we got that the value is 0.03638 meter. Okay. Okay, for the next step is to find the moment of inertia. You must remember how to calculate the moment of inertia. So the moment of inertia about the natural axis is therefore INA equals to 1 over 12 0.15 meter times 0.02 meter cube plus 0.15 meter times 0.02 meter times 0.03638 minus 0.01 meter square plus 1 over 2 0.009 meter times 0.15 meter cube plus 0.009 meter times 0.15 meter times 0.095 meter minus 0.03638 meter square. So the moment of inertia for this section is 9.358 times 10 to power of negative 6 meter to power of 4. Okay, and then the last step for this example is to find the normal stress. Applying the flexural formula, the normal stress at B prime and C is stress at B prime. We use the formula M stress equals to MY divided by I. Okay, so moment we use two 2 times 10 to the power of 3 Newton time and then for y is 0.17 minus 0.03638 divided by moment of inertia. Okay, so we got that the stress at B prime is 28.6 megapascal, and then for the stress at C is 7.78 megapascal. Okay, and then we continue for the equation asks to determine the normal stress at the point B and C. So the normal stress in the wood at B is stress B equals to N times by stress B prime. Okay, so we can use this equation to find the normal stress at B. So equals to 12 divided by 200 times 28.56 megapascal, and then the normal stress is 1.71 megapascal. So the normal stress in the steel and the wood at the point where they are in contact is stress for steel is 3.5 megapascal, and then stress for the wood is 0.21 megapascal. Okay, for the example number 1 for the next topic, which is a reinforced concrete beam. Okay, the equation asks the reinforced concrete beam has the cross-sectional area shown in figure 6-39A. If it is subjected to a bending moment of m equals to 60 kilonewton meter, determine the normal stress in each of the steel reinforcing rod and the maximum normal stress in a concrete. Okay, take a modulus of elasticity of steel is 200 gigapascal and modulus of elasticity of concrete is 25 gigapascal. Okay, for the first step, okay, since the beam is made from concrete, in the following analysis we will neglect its strength in supporting a tensile stress. Okay, for the first step is to determine the property of section properties. Okay, the total area of steel area for steel equals to 2 pi r squared. Okay, so we get the area is 0.3125 pi times 10 to the power of -3 meter square. Okay, and then we can find the A prime. Okay, so we can using this equation. Okay, A prime equals to N times area of steel equals to 200 gigapascal divided by 25 times 0.3125 pi 10 to the power of -3 meter squared, and then we can get the A prime equals to 2.5. Okay, 2.5 pi 10 to the power of -3 meter square. And for the next step is to find the centroid of beam. Okay, the centroid to lie on the natural axis. Thus, summation of y bar times area equals to 0, or 0.3 meter times h prime times h prime divided by 2 minus 2.5 pi times 10 to the power of -3 meter square times 0.4 meter minus h prime equals to 0. So you can simplify this equation, okay, into this, and then you can get that from this equation is 150 h prime squared plus 2.5 pi h prime minus pi equals to 0. Solving for the positive root, we get that h prime equals to 0.1209 meter. Okay, for the next step is to find the moment of inertia. Using this value for h prime, the moment of inertia of the transform section about the natural axis is I equals to this equation. Okay, and then you can get the I is 788.5 to 10 to the power of negative 6 meter to the power of 4. And the last step is to find the normal stress. Okay, this one is the normal stress. Okay, applying the flexural formula to the transform section, the maximum normal stress in the concrete is, using the formula, my divided by I. Okay, so we can get the maximum normal stress in the concrete is 9.2 megapascal. And then for the normal stress resist by the concrete strip that replace the steel is stress prime of concrete equals to my m, this one is m, this one is y, and then this one is I. So the answer for stress prime concrete is 21.24 megapascal. And then the normal stress in each of the two reinforcing rod is therefore stress steel equals to n time by stress prime of concrete. Okay, which is n is 200 divided by 25 time stress of stress prime of concrete 21.24, and then we get the stress of steel is 170 megapascal. Okay, for this is more example that you can refer through the YouTube. Okay, thank you so much. Assalamualaikum.